What's up, everybody? Welcome back. Today we are writing a dbus implementation from scratch. You might ask why, and we can explain. We're running a window manager. Why? We can't explain that one. But we're running a window manager, a Wayland window manager, everything from scratch, right? We're not using any WL routes. We're not using lib Wayland. We're trying to do our best to do everything like from scratch. And we've gotten to the point where, I'm not going to show like window management stuff right now because it's not really ready. Oh no, we just did this. It just worked a second ago. Hold on. We got to restart the VM because sometimes we stop being able to initialize. But we've gotten to the point where we can like render stuff on the screen, which is pretty exciting. And we've been kind of working on input a little bit, right? So we've got to the point where we can kind of show our mouse on the screen. I don't know if this version of the code base is that version. No, this version is not showing the mouse. But anyways, at some point, we're showing stuff on the screen, our compositor's doing some stuff, and maybe we're like typing into this, into our window manager. And we like receive events, great. But also, that typing makes it like behind the window into like the login screen that was here before, right? And so it turns out that what you're supposed to do here is you're supposed to kind of like say, hey, Linux kernel, just so you know, we are in graphics mode now. We're not doing that, right? And so he's not like correctly discarding input. But this led me down this rabbit hole of trying to understand whose job it is to set this graphics mode, right? Presumably the window manager is started by someone, right? I log into my computer, beep, boop, beep, boop. Something's there and it like launches my window manager, and surely if it's launching my window manager, we're already in the right mode, was like kind of my mode of thinking. And it turns out this is true. Hand wavy, when you launch your guy, we kind of learned this like a minute ago, but there's like a bunch of stuff happening as root, over here. One of the things running over here is this thing called login D, and as well as like a system bus, dbus, the thing we're talking about. Login D kind of like registers himself with the bus, and when you log in, hand wavy, skipping a bunch of steps, someone goes, hey, could you give me a session? New session, right? And then I might say something like activate session, right? And the point of this is login D manages a bunch of state that is like not really owned by a normal user, right? So like I, as a normal user, want to render this window on the screen. However, there's only one screen and there could be like 5 users, right? And they might want to be like logged in at the same time. I want to like go over here and I might want to hit the like switch user button, right? And so login D kind of manages access to shared resources like your GPU, keyboard, whatever. Like all of these things that are kind of like privileged, he kind of like manages access to those. And so we have to ask him, could you please give me a term, like give me an area to render the screen? And part of what he does in that list of things is he says, hey, Linux kernel, this guy's using that screen. Can you like not fucking provide, can you like treat it like it's a graphics terminal? We could do that ourselves, but we're going to be using this management system later anyways. And so now is kind of the time, I think, to try to talk to him. And he speaks dbus. Dbus, hand wavy. I don't really know what it is, but I've kind of like heard of it a little bit. I think that what it is there's some guy sitting somewhere, dbus, and he's like a Unix socket, right? Sitting at like some well-known path, or maybe somewhere like specified by some environment variable. And people will like register with him, right? So I think actually right now Spotify is playing, and I think that if I just type like q dbus, I should get a list of like all things that are on here. And I think one of the things that dbus is running is media player, right? So I think that if I like look at, what this guy provides, he might provide me with like notifications as well as maybe like control options, right? On here, I have the ability to call pause and play on this thing. And this is how, when I press like the forward and back buttons on my keyboard, or through this like interface in the bottom right of my screen that you can't see because it's behind my face, you can control this thing, right? So there's like this guy that like every application knows that he's allowed to talk to, and they will like register themselves with him. They'll say like, "Hey, I'm Spotify and I implement media player," and then you can say as like a application, "Hey, is there any media players? If so, could you press pause on them?" And it kind of makes this kind of like generic system interface that is abstract to what thing is implementing them, right? So like GNOME and KDE can both implement desktop, and they can both as an application, you can say that you want to do thing to desktop, and both of them will respond in the way that's like relevant to them. So we, dbus is being used to manage access to things like my GPU and my keyboard and stuff. And so if we're going to implement talking to that from our window manager, we have to implement dbus. So that's where we're at, and so that's why we are trying to implement dbus today. So the plan is we're going to try to find dbus. We're going to try to talk to dbus. We're going to try to suspend like list interfaces on him the same way that this like qdbus utility does. Then call some API, and if we get through all that, that's pretty good. Dbus is what we got instead of plan 9 frowny face is so funny. Yeah. So how do we do that? Somewhere we're going to need to get into an environment where we have our programming languages and such. But when we call qdbus and he lists this stuff, he must be getting it from somewhere. Presumably some environment variable. I think that on I think KDE, when it launches a dbus session for my user, I think. So if I do like mgrep dbus, like we do have this file. So presumably we just open this file and something will happen, right? So I guess let's start there. Stbus. Let's do something. Maybe we want standard library. And open, I guess we could like get the environment variable of whatever the fuck that was. This thing. Session address is this. And then I actually don't want to do this right now because we'd have to like parse that shit out, right? I'm just gonna hard code it for now because I don't really want to write the very minor parsing code that checks if it's Unix path. I guess we can. Fuck it. Extract Unix path from address. Fine. This thing will return another this thing, and I guess it's like this can error, and we're just gonna be like, does address start with starts with Unix path equals, right? If this is not true, return error not Unix path, I guess. And then we will return, I guess it's like tag is this, and then return address from tag len onwards, right? Probably +1. No, it's fine. Okay. Socket path is this, so extract, we're fucking running zig. Extract Unix path from address. We're supposed to use fucking camel case around here. Like this, and then we open this thing. Open file absolute, maybe? Maybe we do pretend it's relative, just in case. Sure. Is this how we, no, it's stud net address, I think, is actually how we're supposed to do this. Init Unix, nice. Socket path. Adder is this, and then we say like, is this tried or something? Adder, we have listen, but I guess we don't want to do that. We want to do like stud net Unix Connect to Unix socket. Oh, nice. We don't even have to do the address thing. We just do it like this. And then I guess what we don't know is, are we supposed to send some sort of initialization message to this thing? Or are we supposed to, does he just like immediately start talking to us? I guess we can try just reading him, right? Var buff, like this. We can say maybe socket reader with buff. And then we can do like reader interface reader, like const IO reader is this thing. And I guess we just like fill more. This thing isn't resolving correctly, but it's like stood IO reader like this. Data is this, and is there anything buffered? Maybe there is. Maybe not. Stood debug print. Let's just see. Did he send some stuff to us, or do we have to send him an initialization? This is more like this. IO reader buffered. All right. Let's see. Zig run main. He's mad. He's mad because this thing, we might not have this thing, or else return error no add session address. Are you gonna parse XML? I don't know. I don't know what the fuck is going on. Who's mad here? Expected this, found this. So socket path here, try here, like fill more, you know, he'd get mad. Okay, so it doesn't look like the bus says anything off rip. So maybe we should look up dbus protocol. Spec, maybe. Okay, so when we connect to this guy, message protocol, I guess maybe we sent him a message. We could just try sending him a message off rip. There's also authentication profile. Before the flow of messages begins, two applications must authenticate. A simple plain text protocol is used for authentication. The protocol is Sazzle. Can we just look up, like, is there some sort of like example? Dbus example. I just want to know, like, you know, off rip, what's he do? This guy's using libdbus. Cheating. Cheating. Native objects, object paths, blah, 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 blah. Can we just look up, like, maybe this is like a question for the idiot, or we should just read the spec a little closer. The spec was probably the place to go. Maybe we try to start doing that authentication stuff. And move on from there. I will say that I have skimmed this spec a little bit, so I'm not just like kind of randomly clicking. I have like looked at this a little bit. I'm assuming. Actually, can we look at like the message format as well? Is one of these messages like, hey, I want to authenticate? Maybe not. Maybe not. Okay, let's read the authentication thing. He's claiming that that's one of the first things we have to do. I'm a little confused, by the way, because I would have assumed that just by like opening the file, we're authenticated. Oh, here we go. Protocol overview. Each line, oh, this is protocol of the authentication thing. So using Sazzle and dbus requires that we define the meaning of a non-empty authorization identity strings. When dbus is used on Unix platforms, a non-empty Sazzle identity represents a Unix user. An authorization identity consisting entirely of ASCII decimal digits represents a numeric user ID as is defined by POSIX. For example, 0 for the root user or 1000 for the first user created on many systems. Sure. So we're 1001, I think. When dbus is used on Windows, we don't care about that. So do we just huck like Do we just huck our names over? Example of a successful external authorization. So we just say auth external this. Whoa. So can I just like send this? Maybe. On Unix platforms, interoperable clients should prefer to send the ASCII decimal string in the form of integer Unix user ID by the authorization. I guess let's just fucking send it and see what happens. Let's just see what happens. Writer. So we'll call this reader buff. And we'll have writer buff. Boom. And can we just be like writer var IO writer is socket writer. Oops. Writer interface maybe? Nice. Okay, so we're like, let's just fucking do this and see what happens. So we want, what the fuck am I looking at here? He says this is the hex encoded string of user 1000 ASCII decimal 1000. Oh, encoded in hex. I see. 1000. So we're 1001, I think. So let's just see if this does anything. Read failed. So he's like, yo, what the fuck are we doing? Right? So if I don't do anything off rip, he's chill. He's just like, nothing's happening. But if we send this, he's not happy. So the question is did we miss something? Before the flow of messages begins, two applications must authenticate. A simple plain text protocol is used for authentication. This protocol is a SASL profile and maps fairly directly from the SASL specification. Can we actually look at like not dmessage, journal CTL? Like, is there some dbus thing that is going to complain at me that I did the wrong thing? No. Okay. Using SASL dbus requires me to find the meaning as non-empty, blah, blah, blah. When dbus is used in Linux platforms, a non-empty SASL authorization identity represents a Unix user. Blah, blah, blah. Authorization is ASCII decimal digits representing a user ID, for example, root user, blah, blah. Okay. So, I mean, it looks like this makes sense to me, but we're not seeing this. Right? So, how can we diagnose what the fuck is supposed to be happening? We just look at the libdbus source code, right? That's the play. I think that's the play. Let's just see what they do. Are you sure you're 1001? Users? No, what am I trying to do? mgrep user? I'm like pretty sure I'm 1001. User ID? ID, there we go. Yeah, 1001. 1001. Okay, let's just look at what they do. Libdbus. Downloads. Libdbus. Hello? Dbus. All right. Can we look for what was we had that like simple dbus example open somewhere, right? Dbus example. So presumably in here, this guy calls his dbus in it dbus bus get. Okay. dbus init something. So no, this is wrong. Dbus error init. Ooh, they have some examples in here too. Okay, let's not get distracted. Dbus error init. Who defines this thing? Oh, this is actually just no. This is initializing an error. I'm a dumbass. Dbus plus get is the entry point. Did I miss the /r/n? Is that what you're saying? Did I fuck up? Oh yeah, I'm a dumbass. Thank you. I thought that I typed that. Yeah, he's still not happy. But thank you. I was a little confused by that. Okay. Dbus get. Was it bus get? So someone defines this thing. It will connect. It will call this blah 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 blah. We have dbus connection open. Is maybe more the interesting piece here. Is that not defined here? Dbus connection open. Here we go. So this guy, if connection is null, he try from address entry. Oh, sure. So this guy, he's like, here we go, new for transport. Oh my lord, that's a lot of stuff in here. But where does he start like fucking sending stuff? Maybe it's done on first message send. That's a possibility. Fuck. Fuck. It's not obvious. Dbus. So then this guy in this example sends like send with reply and block. Does this also have like examples in here? Just like really basic examples? Dbus send. That looks like our real basic example for use of libdbus at least. So he opens the connection. Then he might call something like dbus bus request name. I'm in the wrong folder. Dbus bus request name. Blah, 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 blah. One of these is the definition here. So he, creates a new message, which I assume is not actually interacting with the connection at all. Then he calls send with reply and block. Send with reply and block. Okay. So here he has send with reply. If this is not connected, we have a new pending message. He does a bunch of stuff. Dbus pending. Call unlock. Call and unlock. Was it? Pending call new. Blah, blah, blah. Okay. So the question is does he actually do anything here? This is so much stuff. I want to go back to the spec. Because I don't think that this is going where I wanted it to go. I thought it would be easier. Okay. So. There's a bunch of intro stuff. Okay. Type system is not interesting. Can we look at like Unix domain sockets? The socket address length does not include this. There's a recommended transfer due for dbus as a Unix socket. So we connect to this thing. Not really what I'm looking for. Blah, blah, blah. Nothing in here really seems like what I'm looking for either. This is like more like address, like how the address is supposed to be formatted in the like environment variable. I feel like the correct thing for us to do was run this authentication protocol, right? Which means that we're like not understanding something. There's also like begin in here. What does begin do? It's sent to the client server. The server does not reply. The begin acknowledges that the client has received. Okay, yeah. So we haven't really. It feels like we're supposed to just send auth off rip. I'm okay with saying, let's see if the idiot has any options for us. I'm trying to write a raw dbus client. What are the first steps after connecting to the bus? Let's just see if he tells us. If he says the same thing that we're saying, then maybe we're idiots, maybe we're not. We could also strace qdbus. Authenticate with the bus. Yeah, okay. So, that's my understanding as well. Let's do this. strace qdbus. And can we do temp text? And can we look at, you know, somewhere he's going to say auth, right? Is what we think. Or we're looking for some write syscalls to 3. So he looks like he's immediately starting to send a bunch of shit. Well, let's look at like a, say, open. So we're looking for maybe user one, like run. Env grep dbus. Right, so I would think that we're looking for somebody who's opening this. I would have thought. 1001. Okay. So I guess who's returning this like file descriptor 3? He's got close 3. So he's got the TTY at 3. Confusing. Then okay. I feel like, are we missing stuff in here? I feel like we're just seeing him send the same 8 bytes over and over and over and over. Yeah, like, are we missing some like follow fork or something? Maybe. Let's try that. Right. So there is... Are there multiple PIDs in here? Yeah, there are. Okay, can we look for bus in here? Nice. Okay, here. So we have like a connect here on bus on socket 5. Right? So we're looking for write 5. Oh, maybe send message? Yeah. Okay. So the first thing that he sends looks like it's this, right? So as far as I can tell, this looks like we see org free at the beginning of this thing. So it feels to me. Oh wait, no, here he's got send to here. Okay, wait, that's good. That's good. So maybe it needs to be. Okay, yeah. So he connect socket connect immediately calls send to with a null byte. Then he sends auth external. Okay, so we're missing maybe this, a single null byte, which actually sounds familiar. Actually, did we just miss that? Single null byte. Immediately after connecting to the server, the client must send a single null byte. This byte may accompany with the credentials on some operating systems that use send message with SCM creds or SCM credentials. However, the null byte must be sent on other kinds of sockets. Nice. Nice, dude. Okay, so can we just do this? Invalid escape character 0? Really? How can I not send a null byte? Right byte 0. Let's go! Let's go, baby! That's some stuff. So presumably this is the auth response, right? Okay. And so then we can send begin, right? That's what they said? People watching may be like, bro, what the fuck? Why are we S tracing instead of reading? And I'll say, look, like sometimes this is just the way it's gotta go for me. This is how I learn, okay? You can't stop me. So then he starts negotiating some file descriptor shit, right? That's what he's doing. So let's negotiate. Okay, so he's saying we might want to be able to do file descriptor passing. And so like I guess some messages might require that, so we need to say up front that that's a thing that we want, I guess, which is pretty reasonable. Pretty reasonable. So it's this. Then begin comes after, right? So I guess here, what is the okay response that he's sending? GUID. So is that do I need to use that from now on? The client must respond to the okay by sending begin. Blah blah blah. Which is the GUID server of the server. So I guess we probably just don't give a fuck. We probably just don't give a fuck. Okay, so we're doing some sort of like, we are, I guess, doing like wait for okay from reader, right? And we are going to do something like fill more reader take. How many bytes is this? Is this like a guaranteed length? I guess it's like take until. Take delimiter inclusive. We're looking for a new line, right? Response, and we're like, I guess it's just this. If the response begin starts with, if it doesn't start with okay, return error not okay. There we go. Okay, so we're like, wait for okay on IO reader, boom. Then we print this and we wait for I guess we can kind of like wait for starting with. So here it's like start, and we can be like, okay, so first time we're waiting for okay, but second time we are waiting for the whatever he said, like Unix FD whatever, Unix FD agree. We're waiting for this. What happens if we send some other UID? I assume it just fails, right? But we should find out. I agree. I assume that it knows where I came from. You know what I mean? Yeah, so he says not okay if I send 1001, but if I send 1000, but if I send 1001, we're chilling. Right? Well, theoretically, hold on. I'm surprised. Yeah, okay. So if we say negotiate Unix FD and we wait for Unix FD, why is that not okay now? Did I spell this wrong? Oh, I didn't flush. Don't forget to flush. Never forget. There we go. And then if we did like wait for FC, he gets mad. And maybe here we return, we say what the error type we want to return with. Right, so here it's like error not okay, and here it is error no Unix FD. Boom. Cool. Then we write begin, and everyone's happy. And I guess that means we can start fucking sending some messages, right? That's what QDBus does. They just start fucking, you know, send this immediately. We don't know what this is yet, but we can start looking. So messages. I guess we've kind of found dbus, and we have authenticated with dbus. And so now we are kind of on trying to list interfaces on the bus, right? Because that's what he's doing. So, so the message format consists of a header and a body. The header is a block of values with fixed signature meaning. The body is a separate block of values with signature specified in the header. The length of the header must be a multiple of 8, following the body to begin an 8-byte boundary when storing the entire message in a single buffer, right? So this guy sent 1, 2, 3, 4, 5, 6, 7, 8. Is the length? No. Sorry. I don't know why I thought 8 bytes at first. So this is the header format here. So here it's L or B. So they're saying little endian followed by message type of 1. So message types here, they're doing a method call. Third byte, bitwise or of flags. Unknown flags must be ignored. Sir, excuse me, sir? A single byte can't be a bitwise or of flags, right? There is one flag, right? Am I crazy? Am I high? What the byte is 8. Sorry, yeah. I'm an idiot. You're right. It's fucking 8 bits. I'm just a dumb fucking idiot. Thank you. Yeah. Sorry. I was thinking 1 bit for some fucking reason. Thank you. That would have taken me like maybe 2 minutes to correct in my brain. Okay. So they have flags of what was it? It's like little endian, method call, right? Then they have no flags. So they are expecting a reply. They're allowing auto start of this thing. They're not allowing interactive authorization. Okay, cool. Major protocol version of the sending application. So this is 1. So that is this 1 here. Length in bytes of the message body as a uint32. So 1, 2, 3, 4. Their message body is empty. Okay. The serial of this message used as a cookie. So they are using 1. Their serial is 1. Then an array of 0 or more header fields where the byte is the field code and the variant is a byte variant field value. So here I think that they're saying like the first byte is the message type. So theirs is N. That doesn't sound right. Oh, it actually might. Hold on. The types thing here, they talk about their type system. So their type system has these flags for everything. So they're saying, I am a 2's complement 16-bit integer of 0. This N is followed by 1, 2, 3, 4, 5 bytes before this O. 1, 2, 3, 4, 5, right? That's kind of weird. Unless there's like another type here that we're missing. Let's just double check this again. So the header, an array of 0 or more header fields. Wait, are we high? Serial 1, yeah. Where the byte is the field code and the message type determines which fields are required. Yeah, I'm missing something. Variant maybe is, we forgot this. Alignment 1, the marshaled signature of a single complete type followed by the marshaled value with the type given in the signature. So if we're looking for an int 16 here, we're looking for like 2 bytes somewhere, which means that we're missing 3 bytes somewhere, right? I think. There's also something about alignment here, right? So the header, okay, the signature of the header is 4 bytes followed by 2 uint32s, right? So 1, 2, 3, 4 bytes followed by 1 uint32 is the zeros, 1 uint32 is these. Then we have array. So the array type is the thing that we're struggling with here. So array, a uint32 giving the length of the array data in bytes followed by the alignment and padding to the alignment boundary of the array element type. Ah. Okay. So this uint32 in the header was a serial. So it means that if they want an array here, they need first the length of this thing, which is maybe this. Maybe n was the... Can we look at QDBus with like verbose logging or something? He's like, we can assume that this org free desktop thing is starting to look at like he's looking for some like base object, right? Dbus like default object or something. Like org free desktop The bus itself has this special name, org free desktop dbus, right? So I assume that he is asking this guy to list the like what is registered. Nope. This maybe? Right, so he's probably asking like list all connected names on the bus, right? So okay, so this guy here, object O25, I think is saying I have a 25 byte string, which is an object path. If this is 25 bytes, then we're kind of like on track somewhere, right? So can we do like len of this? 21. Okay, so maybe it's not that. I would love to. Can we strace with like longer strings? Is that a thing we can do? String. String limit. Yeah, let's do this. strace with follow fork. What was this? strace, follow fork, q dbus, and then it was a string limit equals like 1,000. Okay, let's try that. Oopsies, 2 and temp text. And then we're actually just like in a different folder now. Oops. So can we look for, what was it? It was send message. So it looks like, I guess, the 21, 22, 23, 24, 25, 25, 0, 1, 2. So this is, what was it? Python 3. Length of this. So this is 21, 22, 23, 24, maybe with a trailing null, 25. Okay, followed by something here, followed by a string of object name. 6 is maybe length of something. We're missing, or big endian 25. I don't think that, I think that the 25, oh, I see what you're saying. Like you're saying this like 0, 25 is a big endian 25, 2-digit. Yeah, it could be, which would mean that this would be, we're missing, okay, so all we know for sure that these 1, 2, 3, 4, 5, 6 bytes have to be one thing, right? That seems pretty likely, unless this 1 is part of the next O, right? Can we go back to the debug spec here? So we think we're still in the header. And to confirm again, this is an array of 0 or more header fields where the byte is the field code and the variant is the field value. So maybe field code is not 100% clear to me. However, we do see this, the n being the field code makes sense. So unless field code has a different meaning than what I thought. Oh, here we go. The array at the end of the header contains header fields, where each byte field is a 1-byte file code followed by a field value. The header must contain the required header fields for its type message, and 0 or more any of optional fields. Future versions of this. An implementation sees a header field code, does not expect, blah, blah, blah. Don't care. New header fields controlled by the message bus. Here are the currently defined header fields. Ah! So that n doesn't match any of these, right? The one here does. So here this might be, it would make more sense if it was n followed by the array. This is the array length. This is the array length. Okay, so this is a uint. I thought this should be a uint 16 with an n though, not a uint 32 or an int 32. But maybe there's some like padding shit where it needs to be aligned somewhere. Can we look at the array container, the array thing again? Okay, but like theoretically, this, if we parse this right, it's like maybe a array. Array length of 3. This whole section is an array length of 3, right? Because we see one object here, which is the dbus path, then another object, a string here being the name, string here as well. Oh, and then there's like a hello here. So 3 doesn't make sense either. 3 doesn't make sense either. Interesting. We also don't see this thing being like list. We don't see this thing being like list messages or anything. He's just saying hello. Can we look at the dbus interface again? So is hello a thing on here? Yes. An initial message to register ourselves on the bus. Returns the unique name of the connection on this bus. So this guy is calling hello on this thing. Okay? So we can maybe hope that this is a message call somehow. Okay. So in the header somewhere, we have method call. So he's doing a method call. And what happens in the... Okay, so he's saying, I'm doing a method call on path to this guy, interface, right? So we should be seeing a 2 in front of org free desktop dbus somewhere. A 2 is here. Maybe that's relevant. Unsure. Maybe destination 6. It really depends. We really have to like figure out this format. It's the array thing is where we're getting stuck, right? Array of struct. Wait, maybe we missed struct here. We could have missed struct. A struct must start on an 8-byte boundary, regardless of the type of the struct. The struct value consists of each field marshaled in sequence, starting from that 8-byte boundary. Okay, so this struct, it's an array of struct of byte variant, right? Array starts with a uint32 giving the length of the array data in bytes, followed by alignment padding to the alignment boundary of the array element type. Okay. So is it possible there is one of these has to be the length, no? Array of struct of byte variant. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Which makes me think 13, 14, 15, 16. So, which makes me think this could be the length, little Indian, of the array. $110 is crazy large, no? That feels crazy long. Octal 25 is decimal 21. That's crazy, but I guess. Oh, yeah, wait. Also, I don't really understand this format. Is this lead it? Is this backslash 25? Or is this backslash 2, 5? uh, that's confusing. What is the like, strace string escape? How to print hexadecimal string instead of ASCII escape sequence, use -x or -xx. I would love to do that. Right? Can we just do this? This will make my life more straightforward, I think. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So okay, can we do this? Copy this shit into Python. Okay. Wonderful. So here, can we look at this from bytes 12 onwards? N followed by 5 things and an O. Okay, this is kind of the same. This is kind of the same. So if we are expecting our structs to look like what? He said struct was struct. Summary of types. So struct code type R has this thing, but what was like the marshalling thing? A struct must start on an 8-byte boundary, regardless of the type of the struct fields. So can we do 16 onwards? Could be a struct, if we understand this correctly. Each field marshaled in sequence, starting from the 8-byte alignment boundary. Okay. We might be confused about varint. Signature, single byte, content must have a single signature. Okay. So array of struct of byte variant, where byte is the field code. So we should be fairly confident. Array of struct of byte variant. So from 12 onwards, I feel like we have these like snapping points where it feels like the O being the field code makes a lot of sense, right? O for object, which we saw somewhere in this. Right? Object path. Okay? Makes sense. Makes sense. So O being object path followed by a string which is marshaled as a uint 32, 1, 2, 3, 4. Sorry, 1, 2, 3, 4 here. So this is where it's confusing, is like both of these guys have like extra data in them. Right, but if we look at like 16 onwards, we get 15 in hex is 21, which was the length of that string, right? Which was the length of that string? len of this. Aha! Aha! Okay, we're getting somewhere. So that octal thing might have been the call, right? How do you, is it like this? How do you do octal? Yeah. So the thing we were looking at before was doing octal escapes, which is fucking crazy. Which is fucking crazy. The N is inserted by S trace probably. I don't know about that. I don't know about that because we're seeing it in the hex output, right? So we have this hex string that we got from this, and this has like the N as like an actual hex encoded thing in there. Okay, so looking at 16 onwards, the object, we are confident that we have this length of the following string, right? Which means that maybe there's like some padding here. This is at what is that hex 15 at? 20? Okay, so does string alignment is 4-byte aligned, right? So it looks like string is 4-byte aligned, which means that when we get the length of the string, he has to be at hex 20. So it's probably that we have an object padding length name, right? So can we apply that same thing back to this N somehow? I feel like we still haven't parsed out the array length, which is confusing. I feel like that's where I'm getting confused here, right? So we have, this is the message is this, right? So we have message 0. We know that this is little endian. Message 1 is the message type, which we think is, where was the message types? Method call, right? He's calling a function. Message byte 2 is the flags, which is empty. 3 is the major protocol version. Then we are expecting to see from 4 to 8 the length in bytes of the message body. Which is 0? Okay. Then from 8 to 12, we are expecting to see the serial of the message. So 1. Great. And so then we're at the fucking 12 onwards. Array of struct. And what's confusing here is like, why don't we see the length of the array here? An array of 0 or more header fields where the byte is the field code and the variant is a field value, right? So if we like interpret this thing just as a single element, we could maybe argue hello takes no arguments. Oh, you think that the hello is in the header? It could be, right? That maybe here we're looking for the method name is member 3. Yeah. So we're starting with object path interface member. We forgot to change that S trace. Hold on. We forgot to do with string limit. So we wanted S trace dash F with string limit this, and then what was it for dash X? Yeah, okay. Message is this. Okay, so message 12 onwards. We're expecting that we have 3 fields in this thing. Oh, which is this. This is the 3 here, right? So we have the the first string of the object path followed by the interface name. Wait, maybe not. Object path here, string here, string here, string here. So 4. We think that there are 4 elements in this header array. And then alignment. Let's just double check here. So org free desktop dbus, I assume, is hex 14 length. I assume that's kind of what we're seeing here. Yep, okay. Then I assume here, I guess this is unclear what this stuff is. All of this stuff is unclear. Okay. Okay. Okay, so from object path here, we know we're O, alignment, 1, 2, 3, 4 bytes for the length, then the string. Then 1, 2, 3, 4 bytes maybe is something. No, everything in here is, everything up until here is confusing, right? We have string here with length here. That makes sense. So everything in between here is confusing again. There's probably some like alignment here. But there's other stuff here. Let's look at the header fields again. An array of 0 or more header fields where the byte is the field code and the variant is byte variant. With the field value. Yes, okay. The message type determines which fields are required. Oh, wait. The message type determines which fields are required. Oh. Wait. So if we are method call, we need path 1, member 2, then a bunch of optionals. So where does this code come from again? We're missing a marshaled signature of a complete type followed by a marshaled value with the type given in the signature. Is 110 relevant in here at all? Oh, yeah, is it? Because that 128. So, like, it could be a 110 if there's, like, minus 12 for the initial bytes, minus some padding? Unlikely? Unlikely, but, like, not entirely out of... Oh, given the length of the array data in bytes. Wait, maybe you're right. Hold on. Yeah, we might have been getting thrown here. So, a uint32 giving the length of the array data in bytes. That's a good fucking read, right? So here we have 1, 2, 3, 4, which would be 110 bytes, which would be from here onwards. So from 16 onwards is 112 bytes, but there's probably a null terminator on hello plus 2 trailing bytes here. That's not crazy. That's not crazy. I missed that it's in bytes. That's pretty close. Okay, so let's work under the assumption that that is true. So then we are at struct with where does struct has alignment of 8, right? So 16. Ooh, 16 is 8-byte aligned though. right? So we're missing something here. Byte variant. Does variant have an alignment? 1. Okay, so byte is the code here. So we're expecting like 1 means that this is a path, an object path. But then I'm confused about the variant. It feels like we're 1 byte off, right? There's an extra 01 in here, right? Unless, yeah, because we were at 12, so now we're at 16, I'm pretty sure. So, because this was 1, 2, 3, 4 bytes for the array length. Yeah. So now we're at 16. Byte 1. So let's just kind of skip over this for a second. I want to see the next string. So the next string starts here, which means that before the string, he should be seeing somewhere, we should be seeing like interface name. We should be seeing a 2 somewhere before that, which none of these things are, which is a little concerning. Here, maybe though, this could be interface name here. We see a 2 before the string here. I wonder if this is the length of the variant code. Right, so maybe if your variant is longer than one thing. Signature. The length of a single is a single byte. Yes. Okay. I think we got it. So this is 1 byte here is the length of this is I am of type path, followed by I have one byte of signature. Here is my 1 byte of signature. O for object path. Object path then needs to forward align itself to a 4 byte boundary for the length of the string. Then he puts the string out here. I think that we've got through all of this. Okay, so then what the fuck is happening next? Here he should be at the next. We should be looking for the next struct, but structs have to fucking be 8 byte aligned, right? So here, okay, so we're at like 16, like what is this, like 25 or something? 29, 35, 30, 40. So we're looking to get at the end of dbus. 44, 45. Are strings null terminated or objects null terminated? Following null byte, yes. So they are null terminated. So we're at 46 now. And so is 46 a multiple of 8? No. Wait. I don't think so. Yeah. So it would be 48. Yeah. So now we need to bump forwards. Wait, do we? Struct of byte variant. Yeah, so we need to bump forwards to 48 to be on a byte boundary or on a struct boundary. Then we have 1 byte of the argument type. So the next argument is of type destination with 1 byte of variant code length. So we're saying that this is parse the next byte as a variant string. This is S for string. Then move forward to align to a unit 32 boundary for length of 14. I think we fucking got there. Okay, so I think that our goal should be to send this same hello message and serialize it and get the same fucking answer. I think that should be our goal, because I think we understand it now. Okay, so we want to do, okay, let's, this is actually more like understand Q dbus message, and then we are now at send hello, right? That's kind of where we're at now. So we want to serialize. Can we do this? Hello. I guess it's like dbus header is kind of what this type has in it, right? And it was endianness. Do we want to like actually let's actually do this. We'll get to like an actual interface later. Let's just say serialize hello message into SumWriter. Okay, so we're gonna start with const endianness L. And message type is method call. So we're kind of gonna do like this maybe. Endianness is like little as L or big as B. Okay, so this is dbus endianness little. So I guess we can just do like writer write byte dbus endianness little, right? I think this is how we kind of want to structure this. Then we do message type call. Okay. This is going to be maybe we have like flags. I guess we're just gonna do 0 for now. I don't really want to think about that yet. Major version, dbus version, one. I think we just do this. This is a little silly, but it does force us to like name the thing and only have a valid version in here. So then we write the length. So this is so I think that we want to do like write dbus u32. And I think we want to somehow like align forward, right? So I think we want like a dbus writer who keeps kind of track of his position, right? And he's going to have some writer underneath. Okay. And he's going to have like write byte here. And I haven't figured it out yet, but we'll get there. Okay. So what's he going to do? He's going to say self pause plus equals 1, and then he's going to call self writer write byte B. Okay. So now this guy is more like a dbus writer, and we do all the same things. But now we can have like a write u32, right? And he's gonna be like std mem align forward. I don't really want to write this myself. Round address up to the next aligned address. Yeah, how does this work? He just like truncates that thing and then adds one and then adds alignment. Yeah, I don't want to do that myself. That's fine. So we're aligning this to I guess we can just align forward, huh? Um, that's kind of funny. So we're looking at self pause. Oh, I see. And the alignment is 4? Yes, I think. Yes. Okay. So new pause, and we're like, for, we go like self writer fill. No, memset. Oh, I thought there was like a fill on this thing. I could have sworn fill. I thought, am I crazy? Align buffer? No. I could have sworn there was like a memset function on this thing. Like repeat this byte. But I guess not. I could have sworn. I could have sworn, man. Splat. It is here. It is here. So we're splatting 0 to new pause minus self pause times. Right? Then we are doing write int of u32. And we have defined the endianness. So we have like endianness is like what is the little wait, what isn't it like here? Oh, this. So this guy, I'm just gonna, what are you doing? We are writing a dbus client. Dbus client. We're trying to understand at like the lowest level what's it doing, right? So we're not trying to use libdbus, we're trying to write over the socket directly. And see if we can get something that works. What the fuck was I doing? Oh, stood built-in endian. Endianness. Stood built-in endian. You know, technically you can define it however you want, but I think we'll just use our system endianness, right? That seems way more reasonable. So can we use, I think it's like you import built-in here, and then we have built-in endian, like CPU arch endian. Nah, there we go. And this thing, I think, just returns a constant, so I think we're chilling. Okay, so now we can do write u32 of the length of the body followed by the serial of the message. So they wrote 1, we'll write 1. Len serial. Eventually this is going to have to get more advanced, but we have to start somewhere. Okay, so now we are writing the array. So array, how does this work again? Was array aligned? I don't remember. Array is aligned to a uint32. So we're doing this is num headers here. And this is the length of the array in bytes. So I guess we need to first serialize the array content, right? So can we say like header buff here? And can we start writing to this temporarily? Right? So we do like header writer is stood IO writer fixed. header buff. This is confusing. I guess we actually should just seek back to do this, right? So I think that we kind of write this as header len bytes, and I think we write down the position. We say like len pause is, oh, but the fucking writer might not be something that's seekable, so we can't really do it that way. We have to like pre-serialize. Okay. So I guess we like add the alignment later. Yeah, so we're gonna make like a header writer is going to actually be a new dbus writer, I think. Not really sure yet. So var header io writer is stood io write. This is going to be fixed header buff, which I think we can just push in here. Okay. And we'll align this later. So in the header, or this is more like the header field writer. And here we are writing a byte of the of path, right? We want to start with path. So this is the, what was this called? Header field. So we have like path equals 1. Okay. Header field path. Int from enum. Okay. So we write this thing, then it was write variant, right? So in here, I guess theoretically we could just take in anything and like derive the type from what we passed in. But maybe we could be a little bit more explicit about it, right? So here, the first thing that we are writing out is a object path, right? So I guess this is, I guess we write the tag out because object path is like, it's like an object or it's like a string, but it's got a different tag. So we have to be explicit about that. Then we write out, you know, the path of the object, right? Like this. Like this. And so we need a write variant on here. Write variant. And I think we're going to have like the, I want this to be comp time. I think. Maybe not. Maybe not. Okay, so we have the tag here and the val of unclear. Maybe any type. Unclear. We'll do string for now. Or maybe we'll just write like write variant tag here, and then we don't have to think about it. So the variant tag, I believe, is not aligned in any way. 1, right? He can just fucking write that shit out directly. So taglen. So it's taglen plus 1, right? So it's actually like self. We first write out the length of a tag. So if taglen is greater than 255, I guess it's more like tag len u8 is a std math cast of tag len error invalid len. Okay. Then we write out the tag length. Okay. Then we try to write the tag. Right? That seems reasonable. This should be 1. Okay, and then, so we write variant tag of O. And then I think we write string content, we'll call it. So this was that like dbus shit. Something like this. And then maybe we'll have like write object or something later, but like whatever. Maybe we'll call it write string like, actually. I think that's how they called it in the docs. I think that's a better. Okay, so this is S, and we first have to align 4 words and write the length of the string. So we have S len u32 is std math cast u32 S len, or else return error invalid len. We write the u32, and then we just write the string, right? I think. Writer, write all S, and then self pause plus equals S len. I think that's right. That feels right to me. Okay. And so then all we have to do what they did is write the same fields in the same order, right? So do we have that somewhere still? Ouch. So it was path. 6 was destination. Path. Destination. 2 is interface. And then the last thing was the method name, I think, which has to be 5, right? No. Which one of these is the method name? Member, 3. Member. So this was destination 6, interface was 2, and member was 3. And then the destination, we think, is this. We think that the interface is also this. String like needs to be in some cases escaped, no? Great question. Great question. I have no idea, so I'm going to ignore it for now. But yeah, it seems like maybe. That wouldn't shock me. Okay. So we want to add in destination here. Destination as 6. Interface as 2. And member as 3. Oh no, dbus message hex dumps. We're going down a dark path. Yeah. This is a theme. You keep coming in here and saying, ow, don't do that. It hurts. And it's like, yeah, but it's fun. Okay, so this is a destination, which is a string of org free desktop dbus. Then it was the interface. Then the member of hello. Okay, so now we have the length of this header. Ooh, these strings need to be null terminated. They need to be null terminated. Right byte 0. We forgot. You're missing the free on free desktop? Fine. God, you're such an asshole. Fine. I'll fucking type the right words. If that's what you fucking want from me, fine, we can do that. Okay, so now we need to get the header size in bytes, right? So we're trying to write out header len. This is header field writer pause, I think. Wow, alacrity over over other terminators. Because like 10 years ago, I was really into Rust, and somebody wrote GPU accelerated terminal. I was like, cool, I like that. And then I haven't changed since because it doesn't actually fucking matter. For the array length member, do you not include trailing padding after? Yeah. So I think here we need to kind of like do something like writer align forwards to the nearest 8 bytes for struct alignment. Then I think that we can just fucking dump out the header fields, right? Right, so I think it's kind of like this. I think it's something like this, right? Because this struct section had to be aligned to 8, so we write out the length, then align for the struct. I think. And then I think that does the header need to be aligned to 8 bytes? Like, even if there's no body, does the header need to be aligned to 8 bytes? I think it does, right? So I kind of want to do this. You know what I mean? Then do a flush here. I guess this is just serializing. So I guess we can just print this and see what comes out. Yeah, let's do that. So instead of sending this over the wire right now, I kind of want to just hex print it. So can we do test buff? It wraps a stood IO writer fixed on test buff, right? And then, oh, test buff. Can we do, this is like var test dbus writer is dbus writer with a writer inside like this. Okay. And then can we do serialize hello message with test dbus writer? And then can we look at test dbus writer buffered? Can we print this? Okay. He's pissed. Yeah, true, huh? Test buff IO. Fine. Which means, someone else is gonna be mad too. Splat byte is mad about, yeah, I don't give a fuck. I'd think. Splat byte allowing short write. So this should be splat byte all. Should be. We have the same problem at 88 here, where this writer needs to have some tracking data. Header, field IO or something like this. All right. Error union ignored at 92. So true. It's a lot of failies. Okay. 61 is pissed. We can do an int cast here because this, oh, tagline U8 is already here. Wonderful. and then another one at 69, but we can again do like slen u32. We've already cast this thing. Wonderful. No align forwards, right? So align forwards, alignment is, you know, u32 or something, and we take this splat byte shit here and move it down here. Boom. And then we just turn this to self align forwards 4. Alignment. Boom. All right. Yeah, I guess we do need to try, huh? 115, another try. The text at the top of the stream is so funny to me. Divas Bros wanted to be WebSocket so bad but didn't know how to say it. I mean, I think that it's likely that, how do I say this? I mean, Dbus is a lot older than WebSockets, and also WebSockets is a lot of, like, HTTP shit, no? I think that that's, like, an oversimplification, probably. Probably. Can I format as hex? Ow. That's not what I wanted. I guess we'll print it like this, and then we will take the Python thing where we have this hex string and print the same way. Oversimplifications of Twitch chat? I'm shocked. Yeah. Or around here. We've never oversimplified on this stream in our lives. No, not one time. Okay. So can we do something where we go like for what is it? Byte of message. For byte in message. Print byte. It's like this. F byte. How do you like not new line? Python don't new line. End equals this. Maybe we want a little bit of this action going on. Fuck. What is it? Yeah, you say put a B in front. I think you can do it after, right? Byte message bytes add 2 bytes message. I guess we'll just do what you said. Okay. 108. Uh-oh. We already fucked up. We already fucked up. Wait, that's crazy. How do we fuck that up so quick? Message type call? Oh, were we wrong with the message type? Oh, we just fucking wrote the wrong thing here? Hype. Okay. 1. 4 zeros, 1 0 0 0. We got an 86, they got a 110. Right, so our header length is wrong. But we can kind of keep going forwards and see like how we managed to fuck that up so bad. It's the alignment here, right? So the alignment that we added to here, but 86 is really far off. Like really far off. Okay, but okay, so we're definitely missing alignment. Oh, somebody called me on the method call thing a while ago. Yeah, good call. Good call. So what are we let's start with the alignment. Huh. We are trying to. So we need to parse this with our eyeballs again. So it was like message 12 onwards. is where that 110 is. So it was 110 bytes followed by a couple one alignment byte followed by 4 bytes. No, it was 3 alignment bytes. 1, 2. Yeah, what is the 3 alignment bytes for? Oh, it's because the struct needs to be 8-byte aligned, right? So what's the problem? Is this not doing what we want to do? Can we just not write the header stuff after? Like, okay, so here 0, 1, 2, 3. Okay, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Wait, isn't that kind of right? Isn't that kind of right? One, two, three, four for the array length in bytes. Then they're immediately good to start writing. Oh, because the Oh, because 16 was already aligned. This starts at 16. So we are moving forwards even though the header oh. Did we fuck something up here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this should be already aligned, right? So if I comment this out, we get 860000. And if I comment this back, uncomment this, we get an extra 4 zeros, which seems fucking stupid. Is align forward this thing? Oh, he unconditionally adds one. Next or current? No. Okay, so he goes back by 1. No, this should do the right thing. Can we just do this? Like, what am I missing? New pause, self pause. Can we log the alignment too? So for this 8 alignment, well, what the fuck? Oh, oops, self pause. Plus equals. Plus equals. There we go. Much better. I missed a whole bunch. Why are you aligning 8 instead of 4? Struck 7 alignments of 8 for some reason. Yeah. Yeah. Unless I fucked that up. But I think it said 8. Struct 8. Yeah. Okay. So can we print the whole thing now? Now our thing's way too fucking long. Right? We're seeing 150 length now, but let's compare. So oh, what the no, wait, this is fucked. 1, 2, 3, 4. 1, 2, 3, 4. So we have okay, the rest of this though, we can keep going. We can keep going. This is fucked up though. So 1, 1, 1, 10, 0, 21. This is all the same, all the same. All of this is the same until this 115. Then this 115 we see 0006. And they see 06. So we're fucking this up. So I assume that this is 0 is the null terminator on the string that we're passing, that first string. We got the length of the string right for both. 21. So the question is what is going on here? We might not have to align here. Right string like. Right byte. Yeah, wait, what the fuck am I missing here? Because here we write byte, we write variant tag, write string like. Like, in here, we should be able to immediately write the next byte of the destination, right? Right? We write org desktop free desktop dbus, where that ends here with the null byte. Oh wait, no, then we do. Oh, they're padding and we're not. I had it backwards. Because is each struct array of struct of byte variant? Right. So I see what you were saying earlier is that we have to align to struct alignment for each field here. Right? Because like each of these guys is kind of like each one of these is a struct that starts with things. Yeah. Okay, so now still no good? Oh, because we don't know our position? We don't know our position yet. So what I actually want to do is I think I want to initialize this with the position of writer pause here, and then immediately fucking do our align forwards in this buffer. That seems reasonable. Then the alignment is contained in the here. So this is like, now this guy's moved forward, and so we need to subtract our like initial position here, probably. And then maybe this align forwards goes here. This is body alignment. That feels maybe correct. Okay, so now we're chilling until this. We're still not aligning here. That's so confusing. So can we print destination goes here? So this he's seeing 0 alignment issues. Interesting. Okay, can we print message? So we're trying to look for this like bus thing. So 42, 45, 44. So the S in dbus ends at 45. So then the terminator ends at 46, which needs to be aligned forward by 2 bytes. So why aren't we seeing that? We're not seeing that because we're seeing that we're at 32 instead of 46. Very confusing. Very confusing. So, like, how far off? Like, what are we missing? I must have not compared correctly. All the 101 0000 1000 wrong length 00011, then 021, some zeros. The string, I don't see how this could be significantly different. Oh, unless I'm an idiot and hold on. Can we look at 32 onwards? Yeah, there's like no world where we should be seeing that our position is 32, which means that our position tracking just has to fucking be wrong, right? Yeah. Yeah, we're just not fucking incrementing our pause. Like, what are we fucking doing? Okay, there we go. That looks a little bit more correct, I think. But now we're overflowing somewhere. Why? At 122. Whoa, what the fuck? I must have fucked something up here as well. So here, the entire header field length goes from W pause to header field writer pause. All variants except the first one have signature of S. Isn't that right? I thought that was right. It might be wrong. So how come W pause? Oh, because I used W here instead of header field writer in all these places. Oopies. Okay, so now something feels wrong now. It feels like our string is starting way too late. Right? This 47 on ours is like way to the right. So what's happening now? Unless I'm a fucking idiot, can we say should be 12, I think, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Should be 12. W pause. Oh, we did it again. Okay, does that look a little bit more right? Like, what the fuck is this shit? 28 to 21, 450? Hello? Okay, what the fuck? So here somehow this header length is getting like insanely long. Like insane. Which means this align forwards, is it, are we using the wrong unit? No. So he's going like, somewhere he's seeing like 1,000 byte string? How is that possible? Like, obviously not, right? I'm assuming that it's in right string like. No, actually. Right variant tag? Okay, I guess we just fucking write it down, right? Align. Header, field writer, pause. Path O S. All right. And I guess we actually kind of want it like this. We should probably put some fucking new lines. This feels crazy to me. What the fuck? Right, so here we're going from... Oh, hold on. At path, we're at 63. This is like a fucking like 60 byte string somehow. Which seems impossible. Right? Right, U32 aligns forwards. Oh. Wait, this should be equals new pause. It was right the whole time. Okay, so length here is wrong, but it's a lot closer now. I'm confused. I'm confused. Okay, so he goes... Oh my god, everything's too small. 108, 101, 0000, 1000. Cool. Now our lengths are slightly different, but they should be 4 bytes on both of them. Then this guy aligns forwards. We align forwards. They don't. That's why I'm confused again. This bug is back. This bug is back, and it should not be like that. Stood debug print. First alignment. Oh, this needs to have the +4 in here for the length because it hasn't been written yet. So when we start writing for the headers, we need to start offset by the 4 bytes where the length that has not yet been written would have been written. Yes. Okay. So now does this look a little bit more right? 0006. Nice. All of this looks the same until the end of the next string. Then we see 4 zeros, then 21, then 20 padded. All of this looks kind of the same. 100, 101, 115, 107. Okay, we've synced up here. Quadruple 0, 3, 1, 115, 05. All of this looks the same. Here, 2 zeros. This is 111, 000, 111, 000. So our message is actually the same. It's just our length is wrong here, right? So it's probably that our 2 bytes of padding at the beginning and our 3 bytes of padding at the end don't count. 3 bytes of padding at the beginning? Wait, I'm confused again. I'm confused again. 2 bytes of padding at the end, I guess, right? So it's this align forwards doesn't count into the header length, and then we also forgot to subtract the 4 for the length of the array length. So that 110 is back. Let's fucking go! And then is our length right? So this is 128. Can we print ours as well? Test dbus writer buffered len. 126. Oh, because we're missing our fucking trailing bytes now. Why? I'm confused. Do I need to flush? No. Wait, hold on. Oh, we didn't forward, we need to do W pause here is the amount that was buffered. We forgot to actually write it. So can we just do W write all instead? Just so that we can have pause tracking in here? We can never forget. Len U2 is stood math cast data U32 data len, or else return error invalid len. All right. There we go. We got our 128 here. We got our 128. So we should have a message that says hello that we can send to the fucking D-bus man. Let's try to send it and just fucking see what happens. So instead of this guy, can we use IO writer here? And then I guess we need to wait for some response, right? So we do like try IO reader fill more, and then do IO writer buffer or buffered. Okay. Can we say like response here so that I can like fucking see it? They sent us some shit back, baby! Let's fucking go! All right. So we have successfully, I mean, assuming that this is like a valid response, but I think it is. We have successfully said hello. And so theoretically, he should return the unique name of the connection to the bus. So there's probably some like header shit going on in here, you know. We can probably put this thing, can we put this thing as a string? Right, so we see, you know, in here, little endian, we see maybe like him saying, I responded from this interface, from this object path, right? And then here is my like interface name or something, right? Something like that. So now 3 hours stream to decode the answers. Yeah. So I think this is a good place to call it for today, right? Because we're at 2 hours, we're past 4 o'clock, which is usually our like target. We have successfully managed to send one thing to the dbus daemon. What did it involve? It involved us doing a little bit of auth, you know, we connect, we say, yo, I am user 1001, yo, I would like to pass file descriptors, please, and we will start talking. And then we serialized our first message, which was a struggle, but we fucking got there. Alignment, difficult. Where we say hello. And then hopefully tomorrow we can come back and we can start trying to like dump the stuff that's on the bus. Send some more messages to say, hey, could you list all the interfaces, please? And then parse the responses. And if so, that'll be fucking cool. So thanks for watching, guys. If you like what you saw, we stream most days. We aim for 12:30 Pacific time to 4 o'clock Pacific time. It is 4:15 now, so anywhere between 3.5 hours ago and now, you should expect to see us live. We are working on this window manager, which means that we're working on a dbus implementation. There's, you know, lots of stuff in there. Check out the YouTube if you want to keep up. Some stuff goes there, some stuff does not. The stuff that does not is like today was some like we were doing a bunch of trying to understand the like PAM authentication flow. So we did like about an hour and a half of like cloning repos and digging through their code bases, understanding like what does login D do, what does like PAM do, how do these guys all fit together. But yeah, so stuff like that can go in, gets archived on Patreon, YouTube members, Twitch VODs, and if you pay in the appropriate spot, you get access to the VODs. But otherwise, you should be able to follow along fine without that, so no pressure. But anyways, YouTube, peace out. Twitch to find someone to raid.